Trying to escape.
You can be first, and I'll get my stuff out of your way.
Right, that's a lot.
Okay. Good. So people who are waiting, kind of make sure that you're off to the side, backed up a little bit. All right. You can be right there. That's fine, Andy.
I'm special.
All right. Go ahead. Which bullet do you have, Martine?
Yep. D.
He has-
Four. The fourth one. Fourth bullet.
Mr. Craig. All right, we're looking at D. So we're looking at the fourth bullet down. All right, this is what it looked like on his graph. Find D on your little pieces of paper. Everybody find D. And the function is f of x equals absolute value of x. So you could see that he wrote it onto his piece of paper. Go ahead and write it onto yours. Should we make that a tiny bit bigger so people can see? I should write it on mine. Okay, so piece D is f of x equals absolute value of x. Thank you, Martine. Okay, Molly, your writing is really faint. So what is the function there?
The function is f(x) equals the absolute value of negative x.
Okay, this is what hers looks like. F of x equals the negatives in front, right? Okay, so hers is very similar to Martine's. What's different about it? What direction did his go?
Down.
His went up and hers goes down. So notice how similar those two are. So you are finding piece I right now and writing that function on piece I. Are you guys ahead of me? You already got it? Okay, but I wrote what you need to write and it's on piece I. Thank you, Molly. Next. Good. So, which bullet is yours, Jerry?
The second to last one.
Good. Maybe right here, folks. Second to the last bullet. Jerry has function B. Function B. Second to the last bullet. So now you got to find B and copy the function second to the last bullet. F of x equals negative 1/2 x squared plus 2x. Good. That one I got. X. Thank you, Jerry. Who's next? Okay. Is that, which bullet down is that, Oscar?
The sixth one.
Oh, sixth one down is Oscar's, so negative 3x squared, and it's piece F. Find F. Why can't I find these things? Oh, there it is. Okay. Notice also that this told us this was going to be where x is an integer, and that was a clue that it was going to be dotted. All right, thank you. Okay, oh, yours is the last bullet.
Yeah.
So last bullet down for the functions, and it's Q. A pretty complicated one. -2, absolute value x plus 2 minus 4. Thank you. All right, and you have m, and where's m? F of x equals x squared. All right, so I have in front of me F, Q, M, D, I, B from the 6 that you guys just did. Is that what you have? Take all the rest of them and collect them up set them aside. Now we're going to look at these together as a group. So the ones we just did, I'm going to save along with the 2 we did together, but the rest I'm going to put back in my envelope so I'm not confusing myself. Okay? And people who shared today, yes, you may take the pass. Let's see. Look. Yes. Participation went to Andy, Martine, Jerry. I'm making sure I give points. My Oscar, Myra, and Brian, right? Molly, and Brian. 1, 2, 3, 4. Who did I? Andy, did you share? Yeah. Molly, Martine, Jerry. Oh, Myra didn't come up. That was, okay.
Oh, it's the one that goes like.
All right. So now we have all of these graphs, and 2 of them we did together, T and V. I'm going to put them all. What do we have? 8 graphs out in front of me. All of these had an absolute max and an absolute min. And now we're going to take a look at number 3 at the bottom of the page. Somebody to read. Consider the graphs. Thank you, Jerry.
Consider the graph of functions that have absolute minimum or absolute maximum. Do not consider the graphs A and C here.
Okay, it says take A and C and put them away. Okay, we're not using those. So looking at the ones that we have, sort the graphs into 2 groups based on the equations representing the functions, and record the function letter on the table. So now you're going to take a look at graphs like T and F, and graphs like V and Q, and say, what do we notice in these guys' equations? Okay, T and F, V and Q. Let's throw B in there. How about I? If I look at this one, x squared plus 8x plus 12, and this one, negative 3x squared plus 4, and this one, negative 1/2 x squared plus 2x. Is there something those three have in common? Okay, let's look at these. Absolute value x minus 3 minus 2. Negative 2 absolute value x plus 2 minus 4. F of x, negative absolute value of x. They're all combos, but as I'm looking at that equation, this equation, and this equation,
They all have absolute value.
they all have absolute values. Nice. Guess what? That's a family. Our theme for the week are families. These are part of the absolute value family. So on V, I'm going to write absolute value. On Q, I'm going to write absolute. And on I, now I still have over here on the side, I just couldn't fit it on the little thingy there. I still have two other functions, D and M. Who belongs in that family? D. Jackie says D. Do you agree with her? Does it have an absolute value in the function?
Yeah.
Okay, are you guys writing absolute value on all of these pieces? Okay, and now I'm going to write it on D as well. Absolute value. Okay, I'm going to set these aside for a minute so I can get D up there. Okay, again, absolute value, absolute value, absolute value, absolute value. I see it in their functions. What do you notice about their shapes of the graphs?
Or like have a point.
They all come to a point,
And they're all like straight.
and they're all straight. Okay, so you can see how a similarity in their function is also showing up as a similarity in the way the graph looks. Okay, set these guys aside. We still need to figure out T, B, F, and M. We kind of know those guys are a family because that's what we're working on this week, right? And we just found one family. Now we got to figure out what's the same with these. Wyatt.
All the x's have an exponent.
The x's have an exponent. Take a look at T. X squared. Take a look at B. X squared. Take a look at F. I think Wyatt's onto something. X squared. Take a look at M. X squared. Any of them who have an x squared have a special name, and their graphs look, they have a similarity. What's the similarity in the way these graphs look?
They're all curved.
They're curved in like a nice, smooth view.
And they both have a minimum and maximum point.
They either have a minimum or a maximum. These ones are called quadratic. Here's how you spell it. Quad, Q-U-A-D, ratic. Quadratic. So you're going to write quadratic on these 4 pieces of paper. Is that big enough for you to see? Quadratic. Okay, so 4 times we're writing the word quadratic. T, B, F, and M are all in the function family called quadratic. They all have an x squared somewhere in their function. And that x squared gives it this nice smooth curve. The absolute value of x were very similar, but they had straight lines in their curve. All right? Number 3 had us write the letters. So let's go ahead and call group 1, it will be our quadratic group, T, B, M, and F. And then group, did I do something wrong?
No.
Group, the other group was our absolute value group, I, B, Q, and D. What is the same about all the functions in absolute value group? They had an absolute value in the function. In the quadratic group, what did they have in the function? An x squared. So the piece that was the same in this is this absolute value. The piece that was the same in the other group is the x squared. Is that too low? Is this better? In function. Let's see. Ah, that's awesome. This is the minimum of what we were supposed to try and get through today. I thought maybe we'd move on, but I tend to try and pack too much into the day, and then it's a scramble at the end. So I think what we're going to do right now is... No, you're sorry, you don't get to go home.
No, I should go over homework.
Okay.